morning and afternoon, wherever you happen to be at this moment. Name is Michael Smith. I'm an energy engineer and process subject matter expert. I've worked numerous years in oilseeds and other industries. Also, Armed Forces veteran.
And I'm Charles Sanderson. I'm a process chemical engineer. I've been doing a lot of process simulation and data analysis through the years. Applied a lot to oilseeds in particular, but agri-food in more general terms. Alan, do you want to?
Sure. My name is Alan Keogh. I'm CEO of Crowley Carbon, and unfortunately, just only a mechanical engineer. So nice to meet you all, and thanks for your time today.
So folks, we will kick off now shortly in the second in our series, our Masterclass series, and this is Operating Woes in Oilseeds Processing and How to Fix Them. Alan, Charles and Michael will be running the show this afternoon, and we'll have a chance for questions and answers at the end. If anybody has any questions, just type them in the Q&A. Thanks. Alan, I'll let you kick off.
Great. Yep. As I said, thanks everybody for joining, taking some time out of your busy day. This is our second in the series of masterclass events for edible oils, and it's a big increase on the attendance from the last one, about 50% increase. So it's great. Thank you for attending, and maybe some of you spreading the word about this and new people joining. So appreciate it. You've met all us, so we won't spend too much time on us. Just to say that we'll all be delivering the presentation. You want to get sick of our sound of our voices too early or too much. So you may have seen from the emails we've hopefully sent you over the last week or so what we're going to talk about today. So we're going to talk about 9 things in total, so 3 by 3. So the first batch of things we're going to talk about is some unfortunate realities of operating oilseed plants and things we see and things that potentially could be better. Some actionable insights to start to eke some of those percentage savings on energy, steam, KPIs, and process optimization. And then finally, hopefully on a positive note, 3 things you can do today to eke out those percentage wins on energy and process optimization. So starting with the 3 unfortunate realities. So what we see a lot of the time, and hope this may resonate with many of you, is data collection, organization, pulling it out of dark corners, automating the reporting of it, and the analysis and looking for opportunities in the data is difficult and a bit of a mess sometimes, not just in edible oils, but also in industry generally. So what we see is, young engineers, we hire young engineers, and, they're very bright people and very enthusiastic about, making the plant better and doing their jobs as best as possible. But then give them a lot of the time, they're actually just collecting data, going around collecting meter readings, talking to operators, getting operator logs. And then spending half the week putting all that information into spreadsheets, crunching numbers, manipulating, copy and pasting spreadsheets, and not a lot of time actually analyzing the data and looking for opportunities and value in the data. So really, what we're all here for generally is continuous improvement. How do we take that data and continually improve our plant? So make the savings on energy, make the savings on electricity, make the savings process optimization wins. And theoretically, I suppose what we'd like to see, or what customers would like to see, or would like to think they have in place, is a process that looks like this. So on the left-hand side, you've got all the various data sources. You've got a SCADA system, you've got lab information system, you've got various meters, utilities, gas, electric utilities, boilers, cooling towers, operator logs, enterprise resource planning systems, and supply chain. So all that data exists, it's out there, but it's all in various different places. And the idea is that all that information is automatically and continuously brought up to a central point, which is the collator. And the collator is a person or software or both. And that collator is automatically generating really nice reports, looking at energy, yield, optimization, process, product, etc. And those reports then are shared amongst a wider team of experts who can bring their expertise to bear to look for problems and opportunities in the plant. So how do we eke out savings and continuous improvement in the plant? And at that point, they have to take action. So they see something, they see a problem, they see an opportunity, and they have two options, or you have two options. So option one is you can make some maintenance or operational changes, so clean the heat exchanger or reduce the second effect set point, or you can spend some money and put a new heat exchanger in or do some heat recovery. But both paths require expertise to make sure we're doing the right thing, to undertake design, to design some process trials, to make sure that everything's taken into account, that there's no knock-on effects. And then you've got a detailed design if you're putting a new piece of equipment in, implement that, and then ultimately confirm the effect of the action. So make sure that it's actually delivering the savings that you thought it was going to deliver, or the value. And then, as we all know, low-hanging fruit tends to grow back. So you got to maintain those savings over the long term, or the financial people tend to get upset because they gave you $500,000 in capex, and the savings from that have now disappeared. And then the process starts over. So that's the theoretical process of continuous improvement. And Charles is going to talk about actually what we see more regularly and quite regularly.
Yeah, well, so while that ideal does exist, and we hope it's more common than reality, unfortunately what we often see is that critical data is not making it into the day-to-day operation of the plant. There's individual people who are manually collating data, often transcribing it through Excel spreadsheets, sometimes with questionable assumptions and/or copying errors as stuff moves through. Those daily reports are combined with monthly reports for things like energy bills and those sort of things. Those may or may not get consolidated together, but often when they're consolidated, there's further granularization of the data, or sorry, further amalgamation of the data. It's harder and harder to see what's actually happening on the day-to-day of the plant. As you do go through and then try and take action, decide action, you start running into roadblocks in terms of, we've always run the plant this way, or is the data really strong enough to demonstrate it? Or we tried changing that set point 5 years ago, and back then it didn't work, so we're just not going to try and touch it ever again. In terms of the CapEx challenges, did you have the capital allocation ready to go? Did you have the engineer who's able to put together those plans and really flesh out the opportunity to make sure it happens? If you get through those barriers, you sometimes do get through to the take action or implement. But as Alan already alluded to, you don't necessarily have the systems in place to collect the data and clean the data in such a way that you can really confirm that you did get the benefit that you had, so that low-hanging fruit does tend to grow back. To dig into that a little bit more, Mike, do you want to take this one?
So as an example, over on the left, you have your raw data coming into your daily report spreadsheet, whether it's hour averages typically, and you build up your daily report. However, you preload that daily report with your production schedule. So toward the end of the month, somebody says, well, you have to have your daily report in or your monthly report in. So you forward that, but you don't have all the actual data. You have these estimates. Somebody combines that with external utility bills or other water bills and such. Those don't always match up to day 1 to day 31. Sometimes it's the third of the last month to the third of this month. And it's also time delay. So now you have assumptions, you have some raw data, averages, and an accountant will then go in and bring in lab figures and other figures from around, and now you have your KPIs. Well, what's that KPI represent? It represents only a portion of the truth of what you're actually held accountable for in the plant. So you end up with KPIs that are not reflective of how your plant is actually operating.
So what you end up with, and what we end up with, is driving in the dark, and maybe even worse than that, driving in the dark on treacherous roads. It's difficult to run a big edible oils plant or any big industrial facility with those problems and gaps that we talked about. So hopefully in the rest of the masterclass, we'll talk about some possible solutions to these things.
Certainly, one of the things that we see as well in terms of the cold hard facts is that often not all the data makes it into the SCADA. It's not all collated there. Very often the boilers, the cooling towers, the utility systems are missing. And so that's a blind spot that many people have to what's going on there. Understanding the data, filling that gap can be a real opportunity. A lot of plants are built to minimize capital at build time. One of the easy ways to minimize capital is to take out all the instrumentation. Certainly a lot of oilseed plants we see tend not to have very many sub-meters on the steam system. You've got the meter to see how much fuel you're using, but after that, it's a little sporadic. And really understanding where that steam is going, where the energy is being used, can be a critical tool in reducing that overall use. We see a lot of control loops that are implemented, maybe did work once upon a time, or were maybe put in place because they were best practice, but they're not very well tuned. So they're either performing poorly and moving the plant around unnecessarily, or they're turned off entirely and the operator is running the plant in manual. That's an area of real opportunity that we see fairly often in terms of things that can be improved. We also see, as Alan's already said, a lot of time is spent by engineers spending their time collating data, pulling reports, retyping manual sheets, reproducing data in Excel that's already on a SCADA screen, but you just can't download it. That wastes an awful lot of time, and that's engineer time that could be spent either in continuous improvement or in other value-added activities. And that's actually quite a big pool of money if you actually stop and think about how much time people are spending doing those automatable tasks. We also see that a lot of plants don't really have that detailed mass and energy balance. It's a very complex and integrated process. Lots of interactions are happening, but many people are relying on their experience and intuition to work out, as I change things, how would that impact my overall steam use or my overall capacity or yield. Putting together that model and really understanding how the process works can be a big win as well. And then finally, a lot of plants, as Mike has already said, are using either static or monthly KPIs. Getting those KPIs, getting that data into the daily hands or the hourly hands of people who are running the plant can really make a big difference as to the opportunities. And we'll talk a little bit more about that as we go forward. Alan?
So the second unfortunate reality is obviously there's a big opportunity to optimize your existing equipment, DT, VSC, etc. And the first place to go, obviously, for a lot of people is the OEM, whoever originally supplied the equipment to you. But as we see on the next slide, I mean, the incentives for the original equipment manufacturer is not always aligned with your incentives. You know, you typically want to just get more out of the same piece of equipment, and typically they want to sell you new metal, new equipment. And then the other problem we find is that actually, you know, what should the DT be doing, you know, for that capacity, for this bean type, and for winter versus summer? Should it be doing 8 tons or 7 tons? And there's a little bit of ambiguity about actually how the piece of equipment is performing and how it should be performing. And as I say, if you go to the equipment vendor and you say, I think I need more capacity, typically what happens is, well, the solution is a new piece of equipment, which for $3 million. And we have an example of that with Mike on the next slide.
So diving down into a crush plant, the vertical seed conditioner is again a critical piece of equipment, but it's large and complex and actually quite expensive. A customer was recommended by a vendor or by the OEM vendor that their poor performance on their existing VSC with capacity increase request and not meeting temperature and moisture targets, the recommendation was to replace it. So as we came in, we looked at the VSC, we modeled the VSC using the real world data coming from the plant. So their temperatures, their airflows, their performance curves on the fans. And basically we were able to match our model with the plant and with the existing equipment, and we recommended actions. We rebalanced the aspiration airflows, monitoring the ambient air conditions, the delta P across the systems, so that we could dynamically change the airflows as needed. We changed the steam traps so that our utility side of the equipment was efficient, cleaning the air ducts, and installed dust monitoring for continuous performance so that we could track degradation in the system. As a result, we were able to meet the capacity increase, have a 0.5% moisture increase removal and reduce steam consumption. Although this is capital light, it ended up with a 2-month payback for the invested funds, as opposed to a brand new piece of equipment.
So the final unfortunate reality is joined up thinking is hard, especially when you're in the daily cycle of operating the plant and fighting fires and figuring out what's happening in the plant and the interactions between the different parts of the plant. You know, is the tail wagging the dog or is the dog wagging the tail? It's tough to figure out.
So one of the issues that you're faced with is with this disjointed pieces of information, you're looking at your systems. First, you have to get all your data together, your LIMS data from the lab. You want to match up with your run data from, let's say, meal moisture. So you're looking at meal moisture temperatures, you're looking at DT temperatures, you're looking at, and then, oh, let's go over to the shipping department and get the meal ship receipts. And then you have a day delay on your lab samples. None of this is helped by the fact that somebody is over in the boiler house looking at the boiler system on its own, and they change the steam quality or steam pressure. Somebody else over in the lab is changing their lab technique. How does that change the results compared to what's going on in the plant? So it's not only disjointed data that causes very difficult paths forward for analysis, it's also this siloed areas of expertise where somebody making a decision in the crush plant has a direct impact on somebody over in the refinery, but they don't know that, they don't see that.
The other problem that we often see is that, and this is particularly common on smaller operators. You have a team, you have the people that you've trained to do the different parts. You've got them in there. Often you maybe have a really bright young engineer who's come in and done a fabulous job in improving the refinery operation. That young engineer, she's going to get a promotion, she's going to move on to another thing, and suddenly you have a gap in your team. If you're in a larger organization, you can maybe sub in by having somebody from another site double task and work both sides. But if you're in a smaller facility, that can be a real critical issue. And so finding someone who's got a bench of players who can help you fill those gaps on a short to medium term is it can be a really powerful and helpful technique as well.
So moving on to the next section. So 3 insights from our experience. So we've worked in tens of edible oils plants in various geographies around the world at this point. And we've learned a few things that hopefully we can share with you today.
First of those is, and this is maybe a little controversial, but best practice is, in my opinion, an illusion. Best practice is this great ideal goal that you can strive for. There's a list of these are 10 things you can do to improve your facility. And here's an example where for a specific plant, we did go in and implement many of the best practices that you see. And you can see all of them have decent savings. The challenge, though, the reality is that your facility is not the same as everybody else's. The capital that you've installed may be aging and it's expensive to move. You may have a limited area or limited footprint to be able to put different things in. You may be operating at different ambient conditions. You may be at elevation or you may be at sea level, but with much hotter water or much colder air. Those things are all going to impact where you rank on those best practices. And so the best practice for your facility is going to be specific to you. And so the ranking of many different plants in a fleet may not be reflective of what they can actually do. It may just be a somewhat false KPI to be tracking. What we like to try and do is get in there and actually take as much data as possible and turn it into actionable live KPIs. This is an example of something that we did for a crush plant where we were able to take the temperature and pressure measurements of what's happening in the micellar distillation train and take the raw temperature pressure data, run it through a fundamental analysis with thermodynamics, and turn those temperature pressures into actual live concentrations of micellar. The models seem to match pretty well. You can see that the model and the lab data match pretty well. But by having this data live in your hands and actionable right now, you take that 24, 48-hour delay of something went wrong out of the picture. You take the sample happened to be dodgy and so my number's wrong for yesterday out of the picture, and you also have the potential to reduce the number of samples you need to take, saving your operators from getting in there and taking some of these riskier samples and doing things. Putting the data online in people's hands can be a really powerful tool to move this sort of stuff forward. And we've seen value directly coming from that. Mike, another example, quick.
As a example, after you've built your model, you've done your analysis, your model now reflects the specific plant involved. The recommendations that we can go in, whether it's reducing DT temperature, whether it's adjusting vacuum or adjusting flows here. Here you see the actual steam use in the red. As we put in our trial recommendations, the steam use reduced down in the gap to our model results. And the gap between the steam use and the model use is reflected down below in the shaded area. And this is the verification of our model and our recommendations to maintain and achieve what we recommend. So now that not only do you have the results, you now track them. And as we turn the system off, because again, this was a trial, you can see that the plant drifted back to what they assumed was normal operation, but was actually a gap in performance that through continuous improvement using these systems can be achieved and sustained.
So just to add quickly there, Mike, if you go back one, the real power of that for me is, we always struggle with average and static KPIs because they don't take into account the vacuum and the weather and the run rate or the capacity of the plant. But now what you've got is a model which is providing a target line for the operators in the plant to aim for. And it's much more powerful than a static KPI, especially it's continuous, it's within the hour, and you don't have to wait until the end of the week to see what the KPI is. So the other thing we find from, as I say, our extensive experience in working in the sector is people tend to stay in the sector for a long time. It's not unusual to have people for 20 years experience or 30 years experience in a business or in a plant, which is great. There's a lot of embedded knowledge there of the process and operations generally. However, if you go to the next slide, what external people can bring is, like for example, for ourselves, we work in lots of different industries and lots of different facilities, so we bring sometimes new thinking into a situation. So this is a situation of a crush plant on the Mediterranean, a crush and refinery, and being on the Mediterranean, the seawater was very warm during the summertime, over 30 degrees C, and that had two problems. One is it was obviously impacting the vacuums in the various parts of the crush plant and in the refinery, but also it was leading to big infestations of mussels, you can see on the right hand side. So when you opened up the pipes and the heat exchangers and all the equipment, there was just mussels everywhere, which was obviously impeding the performance of the plant. In the refinery, because of this fouling and because of the hot water, the warm water, the vacuum was up to 4.5 millibar, so it was causing really excessive steam consumption in the refinery and actually a derating of the refinery in the summertime. And obviously that was a very stressful situation for the operators and for the plant. However, knowing what we know about absorption chillers, which is a very interesting and robust technology whereby you can put heat into a chiller and it generates cold water at 6 degrees. We found 2 megawatts of waste heat in the plant, and then we put the 2 megawatts of waste heat into the absorption chiller, and it generated nice cold water for the barometric system on the deodorizer. And the impact of it was significant. When it was turned on for the first time in mid-July, it was like a different plant. We were told by the operators and by the plant manager, it was big steam savings, 1.5 tons, nice stable vacuum, 2.5 millibar, and no more refinery derating in the summertime, which was obviously worth a lot of money.
The third opportunity we see is that the plants by the nature are fairly dynamic. There's changes in the commercial terms. So you see this often tension between the commercial team and the operations team, where the commercial team wants to jump on the opportunity of a cheap shipment of beans, or a high price on meal, or a new tocopherol source. That's going to move around how the plant is trying to operate itself. And that can be really challenging for the operators who want a nice stable plant that's operating cool and consistently. And the challenge arises because people are drawing their data from different assumption bases and different sets. The supply chain people may just be looking at the marginal cost of running this type of soybean versus the other type of soybean, not recognizing the fact that there's a significant switching cost to go from one to the other mode of production. The other challenge is that Mother Nature comes into play as well. Every once in a while, a storm comes through. The temperature in summer gets a lot hotter than expected. A piece of equipment fails, and suddenly you can't quite meet your overall capacity goals. There's a number of things that are always changing. Your seed quality. Suddenly you hit a moist patch in your seeds, or a sticky bit of beans coming out of the silo. All those things can have significant effects. And what you want to do as an operator is be as nimble as possible to those changes. Take advantage of those differences as they occur, respond to the problems, and make sure that you continue to operate your plant as consistently and as smoothly as possible. So again, relying on monthly KPIs or KPIs with a 2-hour delay or 2-day delay can be a real challenge.
So final section, you'd be glad to hear. So 3 actions that you can start to work on today and this quarter that don't take major capex to eke out that continuous improvement in your facilities. So step 1, unsurprisingly, we've been talking about this a lot, is to put data to work. There's a lot of data available, as we talked about, between the SCADA, LIMS, ERP systems. So how do we grab that data and put it to work? And I suppose what we're seeing is we have a lot of data about data, and we survey our customers quite regularly, prospective customers and existing customers, and we ask them lots of questions, but the 6 buckets of the questions that we ask them are these on the left hand side. So, you know, how can you, your current system, does it allow you to organize all your organization's data so you can use it effectively? Your current system, does it allow you to access your data whenever you need it, wherever you are? Is it at your fingertips? Does it allow you to view the data through different lenses, so process, CSR, production, etc.? Does it allow you to play with the data to get insights and value out of it and see what's happening in the plant? Does it allow you to collaborate with other people, experts in-house or external experts? And does it allow you to automate the monitoring of the data so you can actually do something more valuable than just crunching spreadsheets? And what we see is when we ask customers the importance of that need and how well served they are currently, you can see in the second and third column, it's very important to customers generally, and it's not very well served by the current systems they have. And applying some of the methodologies and the tools and the software that we're speaking about today, you can see still very important, but a big step change, orders of magnitude improvements in how well served they are by these techniques versus where they were previously. So the categorization of the steps to get continuous improvement and eke out, we call them 3 steps. So first is organize, socialize, and optimize. So organize the data, take it out of the dark corners, put it all together, automate the manipulation and the crunching of the numbers, socialize it, so spread that information to the people who need to see it, the experts in-house and external, and then take action and optimize the plant. So, you know, change the set point or clean the heat exchanger or install the new heat exchanger. So they're the 3 steps. And really the journey we want to go on with customers is go from data scarcity, which is many plants today still don't have enough data, but less and less so these days, to data abundance, but not to stay there, because data abundance can feel like drinking from a fire hose. So there's just too much data, you can't see what's going on. To data clarity, so that the data is at your fingertips and you can see exactly what the problems and opportunities in the plants are and take action to fix them.
So the second thing that's an opportunity is to really build the understanding. As you've heard me allude to already, a lot of what we do is we take the fundamental data that is there from design basis, from fundamental engineering, from thermodynamics. We combine that with real world process data and actual information that's happening in your plant, and build that together into detailed understandings, both in terms of process models and in terms of statistical analyses. Those are great as offline design-based tools and fundamental understanding. But what we like to do is then take that fundamental knowledge, run that into a reduced order model so that we can then put those detailed advanced models in a simplified form into the live data processing system to give you those live KPIs, to give you those live targets, to give you the soft sensors so that you can infer measurements that would otherwise require a lot of time and effort in the lab and give you that information. And of course, once you start getting that greater insight, again, it's another virtuous cycle. It leads back around and you can improve those models, you can improve your understanding of the facility and how things move forward. So really the goal is to move, again, as we said at the beginning, from driving on that dark road where you're not quite sure exactly what's going on, what's going to jump out and grab you from the side, to being on that well-lit highway, a clear road ahead of you, and the opportunity to move forward quickly. Alan?
Yeah, so the final point to talk about is to do all that, to find the right tools. Charles has some, I think go to the next one maybe. Yeah.
Okay, so we'll talk. So what we've tried to do within Crowley is really sort of a dual approach. First off, we've put a lot of time and effort into building a computer system that's able to suck data out of all of those different places. It's got really nice interfaces to be able to read in from SCADA, to read in from Wi-Fi, to read in from SAP. Most tools we can hook into, put all that data, clean that up, turn it into a well-curated, well-understood, well-managed data history. But having done that, we then bring our team of more process-based engineers to play. So we bring that deep process understanding. We've got decades of experience in oilseeds, in boilers, in refrigeration systems, in a range of different processes. We bring all that knowledge together with fundamental mechanistic models to be able to really understand the thermodynamics, the mass and energy balances, exactly how your process is running, and then use that with statistical and data analysis tools to combine all that knowledge together with the actual real world analysis of what's happening. So that we've now not only got this solid database and a great history, we've also got the detailed process understanding. And what that gives you at the end of the day is a series of structured, actionable, and very clear information that hopefully you can then pick up and run with to run your plant day to day, minute to minute, more effectively and more efficiently. Alan, do you want to?
Yeah, and just very briefly about us. So at the core of that methodology that we've talked about today, we have a very powerful cloud-based platform, which does a lot of what we talked about. So it grabs the data, organizes it, sorts it on a continuous basis, and allows us to build those models into the platform. So you can get those continuous measurements of very difficult things to measure, like white flakes and hexane, and target steam consumptions for extraction or for the DT. So that can be all built in the cloud and at your fingertips. So you can really get that augmented reality about how your plant is running. Hopefully with the effect of reducing the KPIs you see on the slide here. So steam KPI, electrical KPI, process yield, etc. So it's really at the core of what we do.
Right.
And just finally, obviously we have some time for Q&A, but thanks for listening to us for half an hour. Hopefully it was interesting. Just two quick messages. If you'd like to see more of these types of events and webinars and masterclasses, please sign up to masterclass at crowleycarbon.com, and we'll send you some masterclass materials, some videos, white papers, etc., and obviously let you know when the next masterclass is coming up. And then secondly, if you'd like to discuss in a little bit more detail about how if you do have gaps that we talked about, how we could close those gaps or how you could close those gaps, we're happy to do a workshop type format, which is a gap analysis to see what gaps may be there and what solutions there may be to filling those gaps. And if you'd like to do that, please email colin.martin@crowleycarbon.com, but we'll send out this information afterwards as well, obviously.
Thank you very much for your attention.
Thank you.
Thanks, guys. That was really, really good. We have a couple of questions there. Michael, I'm going to direct this one to you. And it's, you spoke a lot about crush plants. Have you seen other related processes like biodiesel or animal feed? Do you have an answer for that?
Within Crowley, we've seen numerous integrated facilities, from crush plants, refineries, biodiesel operations. Outside of that has been corn wet milling, refineries, fertilizer. But and again, these crush plants come in flavors. So it's soybean crush plants, it's softseed crush plants, it's palm oil, and refineries come in flavors. You have RBD, straight salad oil refineries. We have hydrogenation facilities. We have transesterification processes. And our approach isn't to generalize, it's to integrate what you have. You have to understand the whole scope, not just of these single processes, but the entire plant footprint. So yeah, there's a lot of background knowledge in not just soybeans, it's across the whole oilseed platform.
Right. Another good one here, I'm going to direct it to you, Alan, because I think you spoke about it. It says, you said not to trust vendors. Why are you any different? Good one.
Well, I mean, our business is all about optimizing what's there as opposed to trying to sell new equipment. So really, that's the difference. And maybe trust, lack of trust is maybe too strong a word. It's, you know, vendors are they sell equipment. That's what they do. We have a different business. We're in the business of optimizing existing equipment. So really, I mean, the first pass should be to see if you can optimize existing equipment, and then maybe at that point, maybe you do need a new VSC or DT, which is, you know, have open that discussion, but at least see if the existing plant or equipment can be optimized, we would say.
Charles, you go with this one. At a high level, what is Crowley's coverage and experience in terms of crush plant experience and expertise on a global scale?
Yeah, well, as Alan said, we've seen crush plants, refineries, oilseed plants around the world. I mean, Asia Pacific, palm oil, soybean, sun, soy, rapeseed, canola. We've seen most types of oilseed. We've tackled plants pretty much everywhere around the world. We have operating bases in Asia Pacific, in North America, South America, and of course Europe is the headquarters for a lot of the operations. So pretty global coverage, and as Mike said, pretty broad application to a range of different types of, but both types of oilseeds and stages of the oilseed process.
So there's another good one here. Mike, I'm going to direct it to you. That all sounds great, but how much is real and how much is aspirational?
The aspirational part is how far you want to take it. This is real data. We basically start the process with asking you a bunch of questions about your plant, and then we present back our analysis of your data. So this is basically, we're not making statements about what could be, we're making statements about what you have.
Right. Gentlemen, thank you very much. And I will.
I think there's one more question, Sinead.
I didn't. Oh, my apologies. Do you have experience in integrating the process data across a few factories under one profit center and do some sort of benchmarking exercise? Charles, you're
yeah.
Alan?
Yeah, well, I think we can do a two-hander on this one. Yeah, so the tool that we talked about, Clarity, it's an enterprise level tool. So it's designed with cloud infrastructure, which makes it very efficient at mapping across an enterprise. So so the answer is yes. We have certain customers who we'd have 40 facilities all on the one platform, and that is obviously the holy grail, to be able to benchmark facilities across geographies and different types of facilities, and we can certainly do that. Obviously, different facilities, sometimes there's danger in benchmarking, because different facilities can have slightly different operating footprints, and one has lecithin and the other has a refinery, and so you just got to make sure that you're comparing as much as possible apples with apples and pears with pears. But yeah, the capability is there, and the platform and the tools that we talked about to do enterprise-wide benchmarking. And Charles,
go
ahead, Mike.
To add to that, the data coming from the plant can be rolled up into whatever package as far as reporting that you want. We can roll up into monthly averages. We can add calculations for sustainability goals. We can do it for specific equipment KPIs or general plant KPIs. It's the limitations we would have is purely upon what data is available coming in. So we can roll up this data into whatever, basically whatever level, whether it's a line supervisor, facility manager, or regional general manager, to create reports. And again, this is all based upon your minute-to-minute data coming from the plant.
Yeah, and the piece I'd throw in to add to all that is, like I said before, best practice can be an illusion. We can roll up and give you those site-to-site comparisons and give you those high-level KPIs of this is how they're performing in terms of kilograms of steam per ton of beans crushed or uptime. But what we can also do is personalize those KPIs as well. What we've seen is sometimes that the facility that appears to be performing best is actually doing best because it's the newest facility and it's in moderate temperature and it's got a nice, clean, stable bean supply that they run 24/7. If you compare that to an old facility at a high elevation with multiple different seeds running through it, that may look like it's operating less well than the nice new shiny facility. But if you actually compare it to where they could be versus where they are, suddenly this facility that's got all the challenges is actually performing pretty close to its potential goal, whereas the new shiny facility may have a gap in opportunity. So it looks like it's performing well, but there's a real opportunity to improve even that best-in-class facility simply because of the way it's operating. It's all about personalizing the data.
Great. Anybody got any more questions? Oh, no.
Thank you for the question.
We got to thank you. Thank you.
Okay, folks, I will be sending out a recording to everybody that joined us here today.
Sinead, just ask a question. If people are still online, is there any topics, we won't cover them today, but is there any future topics that people would like us to potentially talk about? Happy to take feedback and suggestions.
Or drop me an email.
Yeah, either in the chat here or in an email to Sinead or Dave, Colin. Colin would be grateful to get email.
He would. Great. Well, I think we'll give everybody back 15 minutes and we'll finish up.
Great.
Thank you all very much for your attention.